Hello everyone, my name is Dikshit. I am a data science student in FAU. So, today I am going to present a research paper called MapReduce Simplified Data Processing on a Large Clusters. The authors of this research paper are Jeffrey Dean and Sanjay Jimawat. Today we will be discussing the motivation, the main motto of this research paper, and basic concepts of MapReduce, problems and challenges, related works based on this MapReduce proposed approach, and what are the approaches they used in to achieve this, and contributions, validations and use cases, and future works. Finally, the conclusion. Let's start with the motivation behind MapReduce. Large scale data processing involves handling vast amounts of data across numerous machines. Traditional methods requires complex programming and management of clusters, which was very difficult to handle. So, to overcome these type of challenges, MapReduce came into picture. MapReduce offers benefits like automatic parallelization, fault tolerance, input-output scheduling, simplified monitoring, making it attractive solution. Let's know the basic concept of MapReduce. MapReduce is a programming model and a framework that is designed to process large data sets. Initially, the MapReduce is popularized by Google, and then it is adopted by big data processing systems like Apache. The main problem with the traditional method of processing and generating large data sets is the first one is the complex programming techniques. This needs to be involves managing like a data partitioning, task scheduling, communication across the machines, and handling machine failures. These all tasks made complex for developers to focus on core logic for their data processing tasks. So the main challenges for the previous problem is to develop a programming model which simplifies the large scale data processing on clusters, and it also involves to address the solutions for abstraction layer, scalability, and fault tolerance. Abstraction is nothing but which allows developers to concentrate on logic itself, rather than to concentrate on the complexity of distributed systems. And it should handle the massive data sets. Then it should handle the failure by automatically re-executing the task on the healthy machines. In Let's discuss about the related works to the MapReduce. While MapReduce revolutionized big data processing, it wasn't the first attempt at tackling the large scale data. So, before MapReduce, there are some other approaches like SAC, MPI, DSL. SAC is nothing but a split apply combine. It is a fundamental data analysis strategy predicting the MapReduce. It involves splitting data into smaller chunks like this. Let me show. It's it splits the data into smaller chunks like this and apply functions to each chunk, then combine the results. The MapReduce can be seen as a specialized of SAC, providing a distributed implementation. MAP is nothing but message passing interface. It is a standard for parallel programming on clusters. MAP offers more fine control over communication between processes compared to the MapReduce key value model. MAP process more fine grained control, but MAP is not that user friendly compared to MapReduce. It needs deeper understanding for distributed systems concepts. DSL is one of the approach to MapReduce. It is nothing but a domain specific languages method. These languages can offer better performance and expressiveness for certain problems compared to the general purpose MapReduce model. It is again not that friendly compared to the MapReduce model. It is less flexible and requires experts for this specific domain. MapReduce has different approaches. Each approach has its weaknesses and strengths. Now let's discuss about the proposed approach. MapReduce model has two phases for producing and generating large datasets. The first one is the map phase, the second one is the reduce phase. MapReduce is a programming model for processing and generating large clusters. So this model is breakdown into two phases, map and reduce. Allows programmer to specify functions for each phase. Functions process data in the form of key value pair. The key value pair are the inputs. Map and reduce are the outputs as shown in the figure. And after processing in these phases, it gives an output. It's clear, right? So the key and value pairs are the inputs to the map phase, and it generates the other key value pair. It then send it to the reduce phase, and this produce an output. This is nothing but the MapReduce model. Let's see what happens in the map phase. So in the map phase, the input data is in the form of key value pair as discussed in the previous slide. So the key value pair is the input to the map phase. So the applies the user defined map function to the each key pair value, that is input, and it generates the intermediate key value pairs as an output. So the input is a key value pair that applies the user defined map function here for the each key value pair. Then it generates an key value pair as an output, which is known as intermediate key. In the next phase, that is the reduce phase, the generated key value pair from the map phase, that is known as the intermediate key value pair. Those are the inputs for the reduce phase here. So here it applies the user defined reduce function for the inputs or the intermediate key value pair. It produces an output, final output, as a key value pair. So in the intermediate key value pair is shuffled and sort, and then applies user defined reduce function to each key and its associated value, then produce a final pair. So let's discuss the contributions. So before the MapReduce, the data processing requires a complex programming and low level programming language. But after MapReduce is introduced, programmers define functions for map and reduce phases, and the framework MapReduce framework handles the complexities and distributed computing, that is, which is nothing but MapReduce made complexity easy. Enabling scalability, it's nothing but large data sets are split into smaller chunks, as discussed before in the before slide, like split, apply, combine method. This comes here. So the tasks are distributed across the multiple machines in the cluster. This allow efficient processing for massive data volume. So the large data sets is splitted into smaller and then distributed across the multiple machines in the cluster. So this method helps in efficiently process a large data volumes. So as discussed before in the previous slides, MapReduce overcome the challenges for fault tolerance. So whenever there is a machine failure, it automatically re-executed on the healthy machine. So the task assigned to the failure machine, the machine that is failed, will automatically re-executed on an healthy machine. This is nothing but ensuring the fault tolerance. This is one of the challenge overcome using the MapReduce. We all might be wondering where this MapReduce is used and what are the companies who use this MapReduce and why it is used. So let me answer all these questions. MapReduce has been successfully implemented at Google for tasks like log processing and scientific data analysis. This MapReduce is also implemented at Apache and other MNCs, top MNCs. Not only Google just for log processing or scientific analysis, it is also used in social media analytics, financial data processing, and medical researches as well. So after MapReduce, there are some other frameworks has been developed based on the foundations of MapReduce, like in Apache Spark and Apache Flink. These are developed based on the MapReduce. So as it is big data is continually developing, these techniques are also being updated. Coming to the conclusion, MapReduce is the revolutionary for the big data processing. It helped it helped for the many more development, and it influenced the development for the future big data processing solutions. Yeah, that's all about the MapReduce simplified data processing on large clusters research paper. I hope all you understood how the MapReduce model became a revolutionary model for the big data processing, and what are the approaches and the basic concepts of that, and what are the motivations, and what are the companies use this MapReduce model for processing large clusters. I hope you all understood, and yeah, thank you.